Welcome to the 12th and final installment of my series on Earth's extinction events. Today we're continuing our journey through the Quaternary period and stepping into the modern era. If you're new to the series, don't worry, this video stands on its own. But if you're curious about earlier mass extinctions, check out the full playlist. If you'd like to dig deeper, I've linked a document in the description with all the sources and image credits used in this episode. Today, we'll be focusing on the Holocene Epoch. Even if you're not familiar with the name, you're intimately familiar with the epoch itself. You see it every time you look out the window. The Holocene is the second epoch of the Quaternary period, starting at the end of the last ice age, around 11,700 years ago. While the Holocene does have formally defined geological ages, you're more likely to see it broken down by the stages of human history. The Stone Age, Bronze Age, Classical Age, and more recently, the Renaissance or Industrial Age. These divisions aren't particularly useful from a geological perspective, but they do reflect major changes in human technology, which in turn have had profound effects on the natural world. To understand how the Holocene shaped life on Earth, we need to begin with the thing that enabled so much of it: climate. The Holocene began with the end of the last glacial period, but not, as is often assumed, with the end of the Ice Age. In fact, we're still, technically, in an Ice Age today. The defining feature of an Ice Age is not just glaciers, but the presence of permanent ice at the poles. And, by that measure, Earth is still frozen at the edges. What ended was just the recent glacial phase of the Pleistocene, a period marked by dramatic climate swings. Throughout the Pleistocene, Earth's climate followed a pattern of interglacial cycles driven by long-term changes in the planet's orbit and axial tilt. Roughly every 100,000 years, massive ice sheets would advance over much of North America and Eurasia, only to retreat again during brief interglacial warm periods. These cycles were not gentle transitions. They brought swings of several degrees Celsius, reshaping sea levels, ecosystems, and weather patterns over relatively short spans of time. Compared to that climate chaos, the Holocene had been a calm stretch, stable enough for ecosystems to recover and for humans to experiment with farming, cities, and civilization. During a period called the Holocene climate optimum, roughly 9 to 5,000 years ago, global temperatures were often slightly warmer than today, particularly in the northern hemisphere. Grasslands expanded across Eurasia and North America, and deserts like the Sahara briefly bloomed with rivers, lakes, and savannas. Early human societies flourished. But even this stability is relative. The Holocene is only about 12,000 years long, a blink compared to the 100,000-year glacial cycles that came before. From that perspective, it's not so much a new normal as an unusually warm and fortunate pause. And within that pause, there have still been dramatic fluctuations. The 8.2 kiloyear event, for instance, was a sudden cooling episode about 8,200 years ago, likely triggered by a massive outflow of glacial meltwater from Lake Agassiz into the North Atlantic. It caused temperatures to plummet across much of the Northern Hemisphere for over a century. Much later, during the past millennium, came the Little Ice Age, a period of cooler temperatures around 700 to 200 years ago. Glaciers advanced, growing seasons shrank, and severe winters had real impacts on agriculture and human societies, particularly in Europe and parts of Asia. From a human perspective, a 500-year cold snap feels significant, but we probably wouldn't even know it happened if it weren't so recent. It left little to no trace in the geological record. The Holocene feels stable to us because it's all we've ever known, but in Earth's terms, it's a moment of relative calm, and not one guaranteed to last. As the Holocene dawned, the world was already quieter than it had once been. The Megafaunal Extinction that closed out the Pleistocene had stripped away many of the planet's most iconic creatures. And while that wave peaked at the end of the last Ice Age, its echoes continued into the Holocene. In Europe and Asia, the Irish elk, famous for its astonishing 3.5 metre or 12-foot antlers, disappeared not long after the epoch began. Mammoths held on for a few millennia longer in isolated refuges, like Wrangel Island in the Arctic or St. Paul Island in the Bering Sea. Even in the Americas, some mastodon populations persisted into the very first centuries of the Holocene. So while this epoch opened with forest regrowing and climate stabilizing, it was also marked by absence, a biosphere still adjusting to the vacuum left behind. With the giants gone and ecosystems reshaped, a new ecological era began. One increasingly defined not by Ice Age climate swings, but by the growing presence of humans. No longer just another species on the landscape. We were becoming a transformative force in our own right. As the Holocene progressed, the most dramatic changes didn't come from volcanoes or orbital shifts, but from one species, ours. With the climate stabilizing, human societies flourished. Agriculture emerged independently across the world, from wheat and barley in the Fertile Crescent to rice in East Asia, maize in Mesoamerica, and tubers in the high Andes. Domesticated animals followed: dogs, cattle, goats, pigs, chickens. With farming came permanent settlements, and with settlements came land clearing, irrigation, and increasingly intensive uses of the landscape. These changes may have seemed modest at first, a village here, a pasture there, but their ecological impact was profound. Natural habitats were fragmented or erased. Wild grazers were displaced by livestock. Rivers were redirected. Species that had coexisted for millennia with hunter-gatherers now faced new pressures: loss of habitat, competition with introduced species, and hunting at industrial scales. Where mammoths and oryx once roamed, cattle now grazed. Where wild savannas stretched for hundreds of kilometres, a patchwork of fields and fences took root. This wasn't a passive change, or mere adaptation. It was something new. The world was not just changing, it was being converted. At first, these changes were local. A forest cleared here, a predator extirpated there. But as human populations grew and spread across the globe, the impact became global and irreversible. For the first time in Earth's history, a single species was reshaping the fate of nearly every other, and the result has been a staggering rise in extinction rates. Some scientists now estimate that species are disappearing at rates 10 to 100 times faster than the natural background level, the average pace at which species go extinct in Earth's history. This extinction event has been given a name: the Holocene extinction. Some prefer the term the Anthropocene extinction to emphasize it is not merely a phase in geological time, it is one we are driving. Unlike previous mass extinctions, triggered by asteroids, supervolcanoes, or planetary climate shifts, this one is unfolding in slow motion, powered by deforestation, overhunting, pollution, invasive species, and now global climate change. But it may be just as deadly. Extinction isn't always cataclysmic. Sometimes it comes as a whisper: the last airgun hatched, the final coral bleached, the forgotten frog that never sings again. This is the context in which we must understand the Holocene, not as a postscript to the Ice Age, but as the beginning of a new and perilous chapter. A mass extinction unfolding not in the distant past, but in real time. In fact, many scientists now argue that we are living what should be called the sixth mass extinction. The history of life on Earth has been punctuated by 5 great die-offs, devastating intervals where biodiversity has collapsed across land, sea, and air. The Ordovician Silurian, the Late Devonian, the End Permian, the Triassic-Jurassic, the End Cretaceous. These were global, catastrophic, and rare. I have released other videos discussing all of these, along with other, smaller events, so if you haven't watched them already, then do check out the playlist in the description. What makes the Holocene extinction so alarming isn't just the number of species disappearing, but the speed, scale, and the cause. It's unfolding faster than even many past mass extinctions, events that were themselves considered abrupt in geological time. And, for the first time, it's being driven not by natural catastrophe, but by the actions of a single species. As we move deeper into the Holocene extinction, it's crucial to understand the forces behind it. Unlike past mass extinctions caused by catastrophic natural events, this one is driven by a complex web of factors, most rooted in human activity. So, what does this extinction look like in practice? Let's start with perhaps the visible and relentless driver, habitat destruction. Unlike the natural forces that shaped past extinctions, this reshaping is human-led and relentless. As agriculture, industry, and cities expand, ecosystems are carved up, paved over, or transformed beyond recognition. Rainforests fall to cattle pastures and soy farms. Wetlands are drained for housing and developments. Grasslands become roadsides and monocultures, vast stretches of single-species crops that leave little room for biodiversity. Every time a forest is cleared or a river dammed, the web of life it supports begins to fray. And often, it isn't just destruction, it's fragmentation. When continuous wilderness is broken into isolated patches, many species lose the territory they need to roam, migrate, or find mates. Populations shrink, genetic diversity collapses, extinction creeps closer. One striking example is Madagascar. Once cloaked in lush forests, over 90% of its original vegetation has been destroyed since humans first arrived. The island's famously unique biodiversity, lemurs, tenrecs, baobabs, evolved in isolation over millions of years. Now, dozens of species have already vanished, and many more cling to survival in shrinking, fragmented pockets of habitat. Madagascar's story is not unique. From Southeast Asia to the Amazon to the African savanna, the same pattern repeats. Habitat vanishes, and with it, the species that depend on it. If habitat destruction is the bulldozer of extinction, then invasive species are the scalpel. Precise, often unnoticed at first, but just as deadly. And in isolated ecosystems, the damage has been catastrophic. Take New Zealand. Before humans arrived, it was a land of birds, some of them flightless like the enormous moa, which stood up to 3.6 metres tall. With no native land mammals to contend with, these birds had evolved in a world free from terrestrial predators, a blessing that became a fatal vulnerability. That changed abruptly with the arrival of humans. First came the Maori, who hunted the moa to extinction within a few centuries. Then came the Europeans, and with them rats, stoats, cats, and other predators. These animals didn't just compete with native species, they devoured them. Ground-nesting birds like the kakapo and kiwi, unadapted to mammalian threats, vanished from most of their former ranges. Some now survive only through intensive conservation. A similar story unfolded in Hawaii. Roughly 10 million years of isolation had produced a dazzling array of endemic birds, many of them nectar feeders like the iwi or the extinct Hawaiian honeyeaters. But this evolutionary marvel was no match for the cascade of invaders that followed human colonization. Pigs and goats that destroyed habitats, mosquitoes that carried bird malaria, and rats that ate chicks and eggs. Of the more than 50 species of Hawaiian honeycreepers once recorded, most are now extinct or critically endangered. Invasive species don't even need to be predators to cause harm. Sometimes they outcompete natives for food, sometimes they carry diseases, and sometimes, like feral pigs rooting through forest floors, they simply destroy habitats by being there. As humans travel across oceans, over mountains, and into remote corners of the world, we bring other species with us. Some we bring intentionally, others hitch a ride unnoticed. But either way, the result is the same. Ecosystems that evolved in isolation are suddenly forced to confront a flood of alien pressures, ecological, biological, and viral, for which they've had no time to adapt. The Holocene extinction isn't just about what we kill, it's also about what we unleash. Not every threat in the Holocene extinction has claws, hooves, or chainsaws. Some arrive invisibly and kill by the millions. In the late 20th century, herpetologists around the world noticed something troubling. Frogs, toads, and salamanders were vanishing, not just in one region, but across entire continents. Whole populations disappeared from seemingly untouched habitats. Pristine cloud forests, remote mountain valleys, protected national parks. The cause? A microscopic fungus. Batrachochytrium dendrobatidis, better known as chytrid. Chytrid fungus infects amphibians' skin, which for frogs and their relatives isn't just a protective layer, but a vital organ. They breathe through it, they absorb water through it, and when chytrid disrupts that function, the result is fatal. Infected amphibians essentially suffocate or suffer cardiac arrest. The scale of the die-off is staggering. Some estimates suggest chytrid has contributed to the decline of over 500 species and the confirmed extinction of 90. It's widely considered the most destructive pathogen ever recorded in terms of biodiversity loss. Humans did not create chytrid. It is a natural fungus originating from the Korean peninsula. We didn't create chytrid, but we spread it. And the Asian frogs, the ones who would have encountered it naturally, they are highly resistant to its effects. It's the frogs who would have never encountered it who are suffering. So humans may not have engineered or otherwise created this fungus, but what's especially sobering is that we did help spread it, through the global pet trade, scientific specimens, and even the African clawed frog, once used in pregnancy tests, and now known to carry chytrid without symptoms. Unlike deforestation or invasive species, chytrid isn't a weapon we can wield deliberately. But in a world more connected than ever before, the lines between natural and human-caused blur. We don't need to cut down a forest or hunt an animal to extinction. Sometimes, all it takes is moving one frog, one fungus, one invisible killer, and the consequences ripple out worldwide. Amphibians are now among the most threatened vertebrates on the planet, and chytrid is only one part of that story. Not every threat in the Holocene extinction walks on legs or spreads through skin. Some seep silently into the soil, sky and sea, changing the rules of life itself. Pollution wears many faces. It's mercury in a river, microplastics in a bird's gut, nitrogen runoff sparking dead zones in the oceans, synthetic pesticides disrupting insect navigation. It's the slow, cumulative poisoning of the biosphere. Death not by a bullet, but by background noise, subtle, cumulative, and impossible to escape. Consider the case of ocean plastics. Lightweight, durable, and now found from the Arctic sea ice to the deepest ocean trenches. Seabirds like albatrosses feed them to their chicks, mistaking bottle caps and lighters for squid. Turtles choke on bags that resemble jellyfish. And even when it doesn't kill outright, plastic enters the food chain, breaking down into micro and nanoplastics that lodge in tissue and organs, where their long-term effects remain largely unknown. Or take light and sound pollution, disorientating migrating birds, disrupting insect mating patterns, drowning out the calls of whales. Not all pollution is chemical, some of it is sensory, and life evolved in a world without high-frequency sonar or permanent twilight. Some creatures can adapt. Whales, for example, have been recorded changing the pitch and timing of their calls to be better heard over the noise. But this adaptation is stressful, and just one of the many challenges they face. Chemical pollution, too, takes many forms. Industrial compounds like PCBs have been found in polar bears and deep-sea fish. Agricultural pesticides, once hailed as miracle tools, have helped drive declines in pollinators. Bees, butterflies and other insects essential to ecosystems and food webs. In some cases, we didn't even realise what we were doing until the damage was done. DDT nearly wiped out entire bird populations before it was banned. Leaded petrol spread neurotoxins worldwide for decades. And this is the through line. Pollution rarely kills on contact. It erodes, weakens, accumulates. It makes living harder, reproduction riskier, survival less likely. It pushes species closer to the edge, and makes recovery harder when they fall. Like chytrid fungus, pollution is often invisible, but its reach is vast. In a geological blink, we've filled the planet with compounds that no ecosystem evolved to handle. And like the animals themselves, ecosystems have tipping points. Cross them, and collapse can follow. Climate change isn't the sole villain in the Holocene extinction, but it might be the one that makes every other threat worse. The Earth has been warmer before. In fact, Life thrived in hothouse conditions with no polar ice caps and tropical forests near the poles. So the problem isn't the heat itself. The problem is acceleration. In geological terms, climate usually shifts over tens or hundreds of thousands of years. Species can adapt. Ecosystems can migrate. But today, global temperatures are rising at a pace that outstrips most past natural transitions, by at least 10 times faster than the end of the last ice age. Coral reefs, for example, are highly sensitive to temperature. A rise of just 1 degree Celsius can trigger bleaching. We've already lost half the world's coral in just the last few decades, and we're on track to lose most of the rest this century. Ocean warming also drives acidification, disrupting shell formation and marine life and threatening the very base of the ocean food chain. On land, shifting temperatures and rainfall patterns are changing when the plants bloom, when animals breed, and where species can live. Migratory species can't match pace with the shifting climate zones. Mountains become traps, and islands offer no escape. But most of all, climate change acts as a multiplier. Species already weakened by habitat loss, invasive predators, pollution, or disease now find themselves pushed over the edge. A drying forest becomes more flammable. An isolated species loses its last climate refuge. A stressed population finds its food sources gone. Climate change isn't just a new pressure, it's the one that accelerates all the others. And unlike volcanic winters or asteroid impacts, we are the meteor this time. What I've shared in this episode covers only part of the story. There are pressures we didn't even have time to properly explore. Overfishing that empties entire oceans, overhunting that silences forests, the global trade in wildlife that erodes wild populations. The list goes on. The causes of extinction in the Holocene are many, and they're often layered on top of one another, accelerating change beyond what ecosystems can handle. Life on Earth has faced mass extinctions before, but never one has been driven by the conscious actions and inaction of a single species. That may feel overwhelming, but it also means that we are not powerless. Humans have become a geological force, and that also means we can choose what kind of force to be. Across the globe, species once on the brink have been pulled back from extinction through conservation, habitat restoration, legal protection, and public will. The Holocene is still unfolding, and while many chapters have already been written in vanishing ink, the story is not over. The Holocene isn't over. Its ending hasn't been written. What we do next, how we live, consume, protect and restore, will determine what kind of world we leave behind. Mass extinctions are rare. Survival, adaptation, and recovery are even rarer, but they are possible, and they begin with the choices we make next. It's easy to feel powerless in the face of problems this vast, but the truth is, every mass extinction in Earth's history has been shaped by chance and context. This one is different, shaped by intention, choices, and consequences. Which means we also have the chance and responsibility to shape its outcome. I've highlighted the work of incredible organisations in previous videos: the Okapi Wildlife Reserve, International Animal Rescue, the Saiga Conservation Alliance. But they're only a few among thousands doing vital work for biodiversity. I've been lucky enough to contribute in my own way. Through these videos, I try to raise awareness and inspire curiosity. But I've also spent time volunteering with conservation projects in Madagascar, Costa Rica, and here in New Zealand. But not everyone has the time or access to join in the field, and that's okay. You don't need to be a scientist or a field worker to make a difference. You can share what you learn, you can vote, you can support local biodiversity, you can reduce waste, make informed choices, and pressure companies and lawmakers to think beyond the next quarter. These actions might seem small on their own, but a million small actions make a movement. And with enough momentum and courage, we might just write the Holocene's next chapter, not as a mass extinction, but as a turning point. I hope you found this video thought-provoking. The story of extinction is not just ancient history. It's a thread that runs from the first microbial die-offs to the dramatic collapses of the Permian and Cretaceous, and now to the challenges of the Holocene. This series has explored the Great Five mass extinctions, along with many smaller events and faunal turnovers. And now to the challenges of the Holocene. It's a story that is still being written, by us. While these have been some of the most sobering videos I've made, they've also been some of the most important. Because the story of extinction is, ultimately, a story about life. How it endures, how it adapts, how it sometimes disappears. Next time, we'll return to a more familiar format, diving into one of the strangest and oldest animals in the ocean, a creature that may hold clues to the origins of animal life itself. But I hope this series has helped place stories like that, and all of life, in their broader evolutionary context. Thanks for watching, and for joining me on this journey through deep time. And as always, I'd love to hear your thoughts in the comments below.